Hi everyone! Welcome back to another immune system video, where this time we'll be covering vaccines and medications, as well as how we use them to help our natural immune system response. In previous videos, we've discussed the immune system's first, second, and third lines of defense. If you don't remember this topic well or want to review, feel free to go back and re-watch the stages of the immune response video for a refresh, as we will be going deeper into the third line of defense, the acquired immune response. Before modern vaccines, pandemics and major disease outbreaks were a huge problem for humanity. Our innate immune response was working just fine, but the acquired immune response wasn't developed enough and couldn't recognize new pathogens. There are just too many pathogens out there, and without vaccines, people couldn't acquire immunity. Vaccines totally changed this. With vaccines, way less people died of disease every year, and many common infections like smallpox and polio lost their status as deadly killers, hugely improving the lives of billions of people across the world. First of all, let's focus on the obvious question: what is a vaccine? Essentially, a vaccine is a treatment for pathogens which provides acquired immunity to a specific pathogen. It does this by exposing the body to a weakened or dead version of the pathogen so the body can create antibodies for it. That was definitely a mouthful, so let's break it down. To begin with, let's start with what vaccines are made of. The parts of a vaccine are pretty simple. Most vaccines are just weakened or dead injections of the pathogen that we want to acquire immunity for. A really neat way to think of this is like training wheels for the body. The body has time to learn how to fight off a disease with antibodies in a safe environment where it isn't actually in any danger, since the pathogen is a weaker version. Once the body has been exposed to the pathogen, then your body can make antibodies that match the pathogen's antigens. Then, if the body is invaded by the real version of the pathogen, the memory B cells can trigger the antibody immune response, and the pathogen will be fought off much faster, since it can be quickly targeted and destroyed by T cells because it already knows which antibodies to produce. This may seem relatively simple, but the step of getting acquired immunity early is crucial, since without it, the risk of dying in the time it takes to try and develop immunity during infection is much higher. Vaccines can either be monovalent, which means that they provide focused immunity for one pathogen, or polyvalent, which means that they provide a broad but weaker immunity against multiple pathogens. So after discussing how vaccines work, this brings up an interesting question. How are vaccines produced? Well, the first true modern vaccine was invented by a scientist named Edward Jenner, who saw that ranch workers who were exposed to the cowpox virus from cows didn't catch the very deadly and common smallpox in humans. So he tested this by injecting fluid from a woman infected with smallpox into a person that was already infected with cowpox to see if they were immune. He discovered that the person with cowpox was indeed immune to smallpox because they had acquired immunity to the weaker cowpox. And thus, the first modern vaccine was born. However, vaccines aren't our only way of medically interfering with our immune systems. Another way we can help our immune systems is through antibiotics. Antibiotics are human-produced medicines which we give to patients to treat bacterial infections. They can often support the immune response before it has developed acquired immunity to the bacterium by killing off bacterial cells and slowing the spread of the infection. Common antibiotics today include amoxicillin, which is often used to treat ear infections, penicillin, which is the first antibiotic ever discovered, and doxycycline, which is used to treat a variety of infections. And just like antibiotics with bacteria, we can also treat viral infections with antiviral drugs, which prevent the growth of viruses in your body. Sometimes, however, our body can start going rogue and its cells will divide uncontrollably. This is what we call cancer. We often need to treat these cells with cancer drugs, better known as chemotherapy, since our immune system isn't as good at destroying cells that mutate in our body as it is at destroying pathogens. Another type of medication that improves the immune system is taken if we don't get all the minerals and nutrients we need, or our bodies don't produce enough of some essential compounds. In this case, we take supplements as medicine, like Humalog, an insulin injection that treats diabetes, or vitamin D pills for people who can't produce enough vitamin D on their own. The final type of medication that we'll discuss doesn't actually work by helping out the immune system, but rather by suppressing it. These are called immunosuppressants, which actually reduce the strength of the immune system and stop it from doing its job. Now I know what most of you must be thinking. If our immune system protects us, then why would we want to weaken it? Well, immunosuppressants are mainly used for treating autoimmune diseases, where the immune system goes out of control and starts attacking your own body. In order to treat these diseases, patients' immune systems must be weakened so that they don't experience the painful symptoms of the disease. As we've discussed in our transplants and transfusions video, immunosuppressants are also used to prevent adverse reactions to transplants. But if you want to review how that works and more on the subject, feel free to go back and rewatch the video. Now that you've learned about vaccines and the different kinds of medications we take, hopefully you have a better understanding about why it's so crucial to vaccinate and why we take the drugs that our doctors tell us to. Don't forget to do the worksheet and games to review everything that you just learned in this video. Next, you'll learn about how we heal from cuts and the many different processes, cells, and steps going on behind the scenes of a simple healing process.